Hello and welcome to our lesson on functions and graphs. This is going to be from section 2.2 in our text. We've got a lot of material to get through, so let's get started. First, we need to talk about a couple of definitions. You need to know what a relation is. A relation is simply a set of ordered pairs. If you think about what that is, an ordered pair is an x comma y, where the x would be an element of the domain and a y would be an element of the range. So what a set of ordered pairs really does is it shows you a mapping or a correspondence between the domain and the range. Okay? Now let's talk about what a function is. A function is a relation, so it's going to be a set of ordered pairs in which each x can have or corresponds to only one y. So one way to think of this is for your relation to function, the x's have to be monogamous. Each x can have only one y if you want your relation to function. Now the y's can have as many x's as they want and that'll still function. But each x can have only one y for a relation to be a function. And now that we've got those definitions out of the way, we can look at a couple of examples. All right, so the first example we're going to look at is problem number 3. Here we have a relation. We have a set of x's, remember those are the domain, mapping to the y's, which are the range. And if we want to, we could write that as a set of ordered pairs. Here, -5 maps to 1. 5 also maps to 1, and 8 maps to 1. So that's what that relation would look like as a set of ordered pairs. In the text, it wants us to determine if this relation is a function. And the answer is definitely yes. Yes, this is a function because notice that each x value maps to only one y value. Each element of the domain goes to only one element of the range. Now the range goes to 3 different x's, but that's okay as long as the x's are monogamous. And so that is a function. Now let's look at number 4. Here we have the domain, the x's mapping to the range, the y's. Again, we want to determine if this relation is a function, and it doesn't take long to see that we do have an x value that goes to more than one y value. And so this would definitely not be a function. This is not a function because you have a domain element mapping to more than one range element. Okay, this is not a function. And so I hope that helps you be able to figure out when a relation is or is not a function. Moving on, we're going to jump all the way down to number 51 and 55, and we're going to look at how to determine if a graph is the graph of a function. To do that, we're going to use something called the vertical line test, which says if a vertical line touches more than one time, your graph is not a function. So if we look at number 51 and we consider vertical lines, is there anywhere that I could draw a vertical line that would touch the blue graph more than one time? And that answer is no, so the actual answer is yes. No means yes. If no vertical line touches more than one time, then this is yes, it is a function. But if you look at number 55, it doesn't take long to see that we could draw a vertical line that touches more than one time. And It only takes one place to disqualify your graph from being a function. Okay, so this would not be a function. This is not a function. Do you understand that? It's not a function because there is a place where a vertical line touches more than one time. And so that's a brief overview of the vertical line test, showing how you can determine if a graph is the graph of a function. And now we're going to move on to the more exciting problems. Let's move on to problem number 19. All right, for problem number 19, they give us a function, f of x equals 2x squared minus 3x, and they want us to evaluate. So there's going to be several parts to this problem. Part A, they want us to find f of 0. So notice that the 0 is here in the place of the x, which means I need to substitute. Every x is going to get replaced with 0. I call this plug and play. We're going to plug in a 0 and then we're going to work it out. You can work this out manually or electronically. So we're going to do it by hand first. 0 squared is 0. 0 times 2 is 0. 3 times 0 is 0. And 0 minus 0 is 0. Now, to show you how to do that electronically, on my handy dandy Casio ClassWiz, we're simply going to input 2 times 0 squared minus 3 times 0. And do you see I can input that exactly the way it looks over here in my scratch work, and it gives me a 0. So there's how to do that electronically. Next, we're going to look at part C. We're going to skip to part C, and that wants us to calculate f of 2. And so this time we're going to replace every x with a 2. 2 times 2 squared minus 3 times 2. And did you notice when I plug in for x, I always put those values in parentheses? That's just a good habit to get into. And then to do it manually first, exponents come before multiplication. So 2 squared is 4. This is 3 times 2, which is 6. 4 times 2, that's 8, minus 6, which is 2. And then to verify that electronically, look, if I hit this up arrow, it'll bring back what I entered previously, and then I can scroll back and delete and insert a 2. This is kind of a cool thing about the ClassWiz, is you can edit what you previously entered to check a new value. All right, so that's verified. Now let's do part E. It's a part E. All right, f of negative 5. And so this time we're going to plug and play. 2 times negative 5 squared minus 3 times negative 5. Again, doing it manually and then electronically. Exponents first. Negative 5 squared is 25. Here, negative times a negative makes a positive 15. 2 times 25 is 50. Plus 15 is 65. And then to verify that electronically, again, I'm going to go up, back, and edit edit 2 to negative 5. Did you see there's my negative button? Negative 5. And delete. And verified. Yay, man, I love the calculator. And these are so much fun, evaluating functions. Let's try another one. Let's do part F. Now, part F is a little bit different. Here they want us to calculate f of 4x. a, and this time we have a variable as part of what we're substituting. So this is a little bit different. The main difference is you're not going to be able to use the calculator to verify this. But we are going to replace every x with 4a. So that's 2 times 4a squared minus 3 times 4a. Again, plugging back into our original function. And then we're going to have to work this out manually. So what does it mean to square something? It means multiply by itself. So that's going to be 4a times 4a minus, this last part is pretty easy, 3 times 4, that's 12a. And now notice here I've got multiplication all the way across. Multiplication is commutative. That means order doesn't matter. And so I can multiply all of the numbers first. 4 times 4 times 2. That makes 32. And then notice I've got an a times a, which is going to give me a squared. Minus 12a comes down. And listen, that's done. That's where we stop because this is simplified completely. There are no other like terms to combine. There's nothing else we need to do. Part of learning math is knowing when to stop. Okay, you got to know when you've reached your answer. And that's done. And we're going to do one more part, part G, which is not actually in the book. I'm going to make this up because this one's going to be super exciting. This time I want to calculate f of a minus 4. And so this time, if you notice, this time we're going to substitute a binomial. A minus 4, that has 2 terms. And we're going to replace every x with a minus 4. So that'll be 2 times a minus 4 squared minus 3 times a minus 4. And this one is going to be super exciting. Okay, so what does it mean to square something? It means multiply by itself. Notice here I've got a binomial times a binomial, and that's going to indicate the 4-letter F word. You know what that is? That's FOIL. We're going to F it up. We're going to FOIL it. And the negative 3 is simply going to distribute and give me negative 3a plus 12. Negative times a negative makes that a plus 12. All right, let's F it up. Let's FOIL it. A times a squared. Those are the first ones we do. Then on the outside, negative 4 times a, that is negative 4a. On the inside, another negative 4a. And last but not least, negative 4 times negative 4 gives us a plus 16. Minus 3a plus 12 comes down. Next step, we need to CLT. That means combine like terms. So we've got a squared minus 8a plus 16 minus 3a plus 12. And now we can get rid of those parentheses, doing the distributive property. 2a squared minus 16a plus 32 minus 3a plus 12. And now we can finally incorporate the minus 3a plus 12. Let's combine like terms one last time. I've got a 2a squared. He's the only a squared. Minus 16a minus 3a. 6, 7, 8, 9. That's going to be minus 19a. And for the constants, I've got a plus 32 and a plus 12. That's going to give us a plus 44. And that is done. That is the final answer simplified completely. And that's going to do it for evaluating functions. And we're going to move on and look at one more concept, and that's going to be graphing functions. We're going to look at how to graph functions. So the first example we're going to look at for graphing a function is number 39. And in this problem, we have f of x equals 2 minus the absolute value of x. This is an absolute value function. We're going to use a table of values to sketch the graph. And just to give you a heads up, an absolute value function makes the shape of a V. Just remember that V is for value. Absolute value makes a V. And I'm going to teach you my technique to minimize the amount of points you need. So the first thing we want to know is, what number would I replace x with to make the absolute value of 0? Well, that would be 0. We're going to replace x with 0 to create the absolute value of 0. That's going to be our center point, or in other words, the vertex of the V. And then I'm going to need to pick another x, one on each side of 0. So a number right below 0 would be -1, and a number right above 0 would be +1. And those are going to be the three x's that we need to substitute in order to get the y's so that we have 3 points to plot. Now, doing the work. First, we're going to plug in -1. The absolute value of -1 is 1, and 2 minus 1 is 1. And there's our first ordered pair. Next, 2 minus the absolute value of 0. Well, the absolute value of 0 is 0. 2 minus 0 is 2. And there's our vertex. That's our second point. And last but not least, plugging in +1. The absolute value of 1 is 1. 2 minus 1 is 1. And I can't help but point out the symmetry here. Do you see how those y's are the same? This graph is going to be symmetric. All right, to the axis. Here we've got our x-axis and our y-axis. You're going to need to know how to plot points. So our first ordered pair says if I go to -1, I'm going to be up at 1. At 0, I'm going to be up at 2. And then if I go over 1, I'll be up at 1. And if I play connect the dots, you can see that I get a V upside down. It's an upside down V. Absolute value functions make a V. And just on a side note, the way you can tell if it's going to be right side up or upside down is if there's a negative in front of your absolute value. A negative in front is going to flip it over and make it an upside down V. And that's it for that problem. That gets the graph done. We're going to look at one more before we close out this lesson. Number 42, g of x equals the absolute value of x plus 3. So this is another absolute value function. It's going to make a V as a graph. But this one's a little bit different because we have a number inside the absolute value. And so we're going to have to be careful about the x's we pick. Okay, so remember, the first thing you need to ask yourself is, what number could I replace x with to make the absolute value of 0? What number can I plug in that'll make all of that stuff 0 inside? Well, that's -3. And so that's going to be my center point, or the vertex of the V. And then I need to pick a number less than -3 and a number greater than -3. So -4 is 1 unit less than -3. -2 is 1 unit greater than -3. And it's nice if you stay symmetric, 1 unit below, 1 unit above, and that'll keep your y's symmetric. Now let's plug and play. First, we have the absolute value of -4 plus 3. Working that out inside, -4 plus 3 is -1. And then I can take the absolute value and get 1. Next, -3 plus 3 is 0, LOL. And the absolute value of 0 is 0. And one more time, replacing x with -2. -2 plus 3 is 1. And the absolute value of 1 is 1. And now we can go to the coordinate system, plot our points, and connect the dots. So at -4, I'm going to be up at 1. At -3, I'm going to be on the axis at 0. And at -2, I'm going to be up at 1. And connect the dots, and we get our V. Oh, and notice that this was an upward facing V, again, because in front of the absolute value this time it was understood positive, so that's an up facing V. And it is kind of interesting to note that this V is shifted from the origin to the left 3, and that's because we had that number inside the absolute value. And that'll become more important later when we talk about graphing using transformations. All right, that's going to do it for this particular lesson. If you have any questions or comments, feel free to leave those in the comment section below, or you can text me. And thanks for watching.